Good morning and welcome to today's Electronic Design Webcast. Our topic today, simpler systems monitoring, how to offload multiple functions to an MSP430 microcontroller, sponsored by Texas Instruments. I'm Bill Wong, Senior Content Director with Endeavor's Design Engineering Group. To begin, let me explain how you can participate in today's presentation. First of all, if you have any technical difficulties during today's session, simply hit F5 to refresh your webcast console. If you need assistance solving common issues, please click on the yellow help icon below the slides. This webinar interface allows you to resize the presentation by clicking on the maximize icon or by dragging the lower right corner to enlarge the window. Additionally, we welcome your questions during today's event. We will answer as many questions as possible during the Q&A session that will follow the main presentation, but please feel free to send in your questions at any time. To do so, simply type your questions into the question window on the side of your screen and hit the submit button. Also, please be aware that today's session is being recorded and will be available on the Electronic Design website within the next week. You'll be notified by email when the archive is available. Now let's meet today's speakers. Sheena Patel works at Texas Instruments as a product marketing engineer focused on the MSP430 microcontroller products. J.D. Crutchfield joined Texas Instruments in 2012 as an applications engineer. Over the last 8 years, he has held roles in applications, systems, and marketing across TI's digital products. You can learn more about our speakers by clicking on the blue Speaker Bio widget on your console toolbar. Now let me turn things over to our presenters. Sheena and J.D., the floor is yours.
Awesome. Thank you, Bill. So hey, everyone. My name is Sheena Patel, and I'm from the MSP430 marketing team. So I think Bill introduced our topic pretty well, so we'll go ahead and jump right into it. So we wanted to kind of run a survey before we get started today. So the question is, and feel free to go ahead and click the button to vote. The question is, how often do you use a secondary MCU? We also, can call it a housekeeping MCU in your designs today. And so the options are often, sometimes, I never use a secondary MCU, or maybe you don't have much experience with MCUs. So you can go ahead and vote, and then we'll look at the results. Okay, cool. So it looks like people are sometimes using a secondary MCU. And so I think this is a really, we'll have a good discussion today. Because definitely want to show you guys what we have around going and implementing a secondary system monitoring or housekeeping MCU in your application. And so I think hopefully this will be relevant for those of you. And then for people who maybe don't have a lot of experience with MCUs, we'll also be able to show you how you can go ahead and get started. So let's go to the agenda. So like I mentioned, we're really going to dive into today how you can go ahead and take a very system level approach to selecting a secondary MCU. And this is something that we see a lot of our customers doing. And so for many people, it might be a review, but we really just want to show you how to go about doing that. And then also the why you would want to go and add a secondary housekeeping MCU to your application. And we'll run through an example design scenario to kind of show the trade-offs and some of the benefits of doing this. And we'll also cover some of the products that we have from our MSP430 portfolio that really enable you to go and implement this housekeeping functionality in any of your applications, really. And then JD will run through a demonstration of some of the software examples that we have, as well as the TI Cloud Tools ecosystem that we offer. So let's go ahead and get right into it. So like I mentioned, this is something that we see a lot of our customers doing already. If you can look at this board and kind of imagine the MCU is that center chip, as customers are starting to go and integrate or starting to go and add more functions to their board, say they need to do something like a timer and they need to add, they need to put an IO expander, maybe add some external memory like EEPROM. The board size is getting bigger, and customers are having to then, go put more components on the board, route those up, and there's just a lot more design consideration that has to go into your system at that point. At the same time, microcontrollers are becoming a lot lower cost than they were in the past and a lot easier to use. So in some cases, MCUs today are very simple. There's just some memory pins and some basic peripherals. And so it is becoming a lot easier to just, plop a secondary MCU onto your board and start integrating some of this functionality onto it. So this is exactly what we're starting to see a lot of customers doing. But we definitely understand that maybe people, everybody's microcontroller experience is not the same. Some people have a lot more experience and maybe you're pretty new to microcontrollers. And so we really want to show you what we have to enable you to get started integrating some of these discrete component functionalities into a single chip. So we're going to run through an example design scenario to kind of show how and why you might go about adding that secondary MCU. And so if we were to look at it from a discrete component approach, it's maybe something that customer might do in the past. I'm going to run through an example scenario. Say I wanted to, control a few LEDs. So I would put down an LED controller IC. Maybe I needed some external memory. So I put down an EEPROM chip, need some IO expansion, and an external watchdog timer. And of course, you have your main host MCU or your processor. So for your total system BOM with this very basic application, you're looking at already 5 components on your board. You can imagine that this can get a lot more complicated as you need to add more functions to your system. So this is a really basic example, but as you can see, you're already having to consider, adding 5 parts to your board. So now if we look at it from an integrated approach and we look at the same board and the same system, and we say we're going to try to replace all of these discrete components with a secondary MCU and really take out all of the additional devices that are needed to go and perform some of these very specific functions and integrate them into software that's running on that secondary MCU. There's definitely some benefits to doing this. And so not only from, I think what we really need to look at now is how do we go about doing that? So from a software perspective, what does it take to go and take these functions and go and put them on a secondary MCU? And then, of course, what's the benefit to you? What's the benefit to you as a customer in doing this? So if we look at it from a memory footprint perspective, this helps us understand what kind of microcontroller would we need and what size, what memory size would we actually need on our MCU to be able to go and integrate all of these discrete functions into a single MCU. And so the memory footprints that we're going to show right now, we actually are able to show you because we have software examples for each and every one of these each and every one of these functions that we're showing. We have more than just this, and we'll show that at the end, but we do have code examples for MSP430 devices that basically do all of these different items, and that's where we're getting these numbers from. So to go and integrate an LED controller controlling 3 LEDs in software, you're looking at about 1K of memory. For an IO expander, another 0.36K. Say I wanted to emulate 4K of EEPROM in my FRAM memory on the MSP430 MCU. You're looking at obviously 4K of FRAM, and then also another 0.33K to get that set up. And then say I wanted to add an external watchdog timer in software, another 0.37K of memory. So all in all, to go and implement this into an MCU, you're looking at a memory footprint of about 6 KB. So typically you'd probably go for something like an 8 KB device with that much memory on it. So that's kind of how you would go and look at it from a software overhead perspective. But what about some of the things like cost? What about the BOM savings? What are some of the benefits of actually going and doing this? And so what I actually did was I went on the internet and I looked at the web pricing for the discrete versions of all of these devices and looked at it from a web pricing perspective to help us better understand what it would take to go and implement this in a discrete manner like we showed at the very beginning. So for each of these chips, you're looking at about a total system cost of 96 cents. And that is looking at, a separate LED controller IC, IO expander IC, a serial EEPROM chip, as well as a watchdog timer. This is the total cost for this system. just based off of what we're looking to implement in the system. Now, like I mentioned before, the right device probably for this application would be an 8 KB MSP430. And the pricing for that today is 23 cents. So already you can see there's some benefits here from purely a cost perspective. And I think that's really important because maybe in the past, that's something that held a lot of customers back from going and doing some of this in software. That's maybe just one benefit because not only are you seeing BOM savings, but you're really in general simplifying your design because you're not having to put down as many parts on the board. You're not having to wire those up, have the schematic and layout considerations for adding all these additional components. With a secondary MCU type of approach, you're really simplifying your design by reducing the number of parts that you have to have not only in your BOM, but on the board and having to, having to have all those design considerations. Those are really minimized with this type of approach. So the devices that we are really targeting for these kind of housekeeping or system monitoring type of applications, if you really need to just do a couple of things in your system, just a couple housekeeping functions, you probably can get away with a lower memory device. I think the scenario we had before, there were several functions that were being mixed and matched. But if you don't need that many, you can get, you can get a really small device with as little as half a K of memory. And on TI.com today, that part is selling for 17 cents. And so, you can imagine at volume, this pricing can get even better. But purely from, what you can go and buy today, these are the kind of price points that you're looking at. And then say you needed to go and implement a few more functions, like in our previous example, we identified an 8K part. These devices, again, are pretty cost competitive, going up to 64 KB of memory in this family. And as you can see, the most expensive part on this list is 83 cents, which is still cheaper than the total system cost that we saw of the discrete components in the previous scenario. And 64K is quite a bit for a housekeeping MCU. And so generally, you might be more in the 16K and below range. As you can see, the pricing there is very good online today on the TI store. And then I did mention that we have several other code examples that show off some of this, system monitoring functionality. We have all of the code, the memory size, the memory footprint, and code size of all of these examples shown right here in the right-hand column. And there's actually more than just this list shows. There's actually 25 of them. So you can go ahead and go on TI.com today, and we're linking all of the the specific pages to go and actually find some of these code examples. But as you can see, the memory size is pretty small for a lot of the code size is pretty small for a lot of these examples. And so it becomes very easy to then take a few of them and then, pull them into your project and start mixing and matching them, combining them together and really building out your entire, building out the software for your housekeeping MCU. And so with that, JD is going to go a little bit more into this topic and how you can actually get started with using our hardware ecosystem, some of the cool cloud tools we have, as well as these code examples right here. So I'll go ahead and pass it over to JD.
Thanks, Sheena. So this is I'm JD Crutchfield. I'm an applications engineer with the MSP430. And today I'm going to take us on TI.com and kind of give us a live demonstration of the software that we have available, as well as our cloud tools. So give me 1 second.
And JD, while you're doing that, I'm going to quickly go through the next poll, if that's okay.
Okay.
Or do you want? Okay, sorry.
Let me do the live demo.
Okay, let's go to live demo.
Okay. So as Sheena mentioned, as these parts are getting much cheaper, MCUs are getting much cheaper and more competitive, they're starting to approach on these, typically like analog or standalone components. So we do have an ebook that we'll be linking that simplifies all of these 25 functions for under 25 cents. I just wanted to give you a quick introduction to it here. So you'll see that, again, all these functions are kind of broken up into different sections. We have certain examples for communication functions, PWM, a lot of generic kind of system and housekeeping functions. So a really common one we're seeing a lot of customers will be like this multifunction reset controller and then add in some of these other features. Today, just as a brief example, I'm going to use the UART software controlled RGB LED like color mixing example. So this is a basic LED kind of controller example, but I just wanted to show when you click on this, what you'll get is you'll get 1 or 2 pages that will explain the application, explain the demo code, link to all relevant resources. So everything you need will be in 1 or 2 pages here just to read through what's going on. And here you can see there's going to be a download file to get all of the code for the examples. So again, this is what Sheena had shown previously, but this is where you can actually download all of the example codes that Sheena was talking about for all the different applications. So again, these are going to be built on several of our peripheral examples put together, and then have kind of a direct one-to-one comparison to those chips that we saw earlier on Sheena's large board. All right, so I want to give you a quick introduction to our kind of development ecosystem, if you will. First things first, I want to start with our development kits. So if you're not familiar, our Launchpad development kits are always the best place to start for either evaluating a device or actually doing some development. These are very cost-effective EVMs that are easy to use. You'll see down here there are several different offerings that have different memory sizes, different features. Today we're going to focus on this MSP430 FR2433. Again, this was on the list that Sheena showed earlier, but this is just a 16K memory device with some very general peripherals. And again, it's also one of our lowest cost launch pads. So real quick to give you just a view of what the Launchpad looks like here. So again, it's going to be a fairly easy to use board. This top section here, this is a built-on programmer. So all you have to do is plug this into your computer via USB, and this is going to be your complete download and programming as well as your live debugging tool. So this is going to give you full functionality for doing all your development and debugging. And then down here in the bottom half, this is actually the target device that you'd be evaluating. So this is the 430 FR2433. You can see it's got a couple switches here on the sides, a couple LEDs, and then just like some breakout headers. So a very simple EVM, very easy to use, programmer chip all in one for $10. So again, best starting point from a hardware standpoint. Real quick, I want to give you an introduction to our software and GUIs and IDEs, specifically Code Composer Studio. So if you're not familiar, this is an IDE, a software development tool that TI provides that we've put out and maintained. It's a free-to-use tool, no licensing or anything, so completely free to use. There's both a downloader and a cloud development platform for this. Today we're going to look at the cloud development, but it's just a very, very powerful Eclipse-based IDE. And integrated into Code Composer Studio is what we call our MSP430 Ware. So this is actually going to be a collection of all of our design and development resources for MSP430s. So this is going to include all the example codes for all of the MSP430s, as well as any software libraries and some documentation, these types of things. And this is going to again be integrated into Code Composer Studio. So when we come into the MSP430 Ware page, again, today I'm just going to show you the cloud version. So this is all hosted on the web. So when I click into here, so what we're going to see is MSP430 Ware lives in something called Resource Explorer. So Resource Explorer is where our software is hosted. This is not only for MSPs, but for basically all of the MCUs across TI, so including our wireless chips and some of our C2000 chips. So anything that you need for software development resources for all of our MCUs, like this is the place that you want to end up. And again, this is integrated with Code Composer. Today, I'm just going to show you where to find the example codes, what they look like, and then how to import them. So you can actually navigate via device and like navigate down to a specific part number. But the easiest place to start is to start with development tools. And this is going to be sectioned off by the different EVMs we were seeing. So you'll see all of the launch pads listed here. Again, today we're going to look at the 2433. So as I navigate down here, we're going to come into this peripheral example. So these are going to be our lowest level kind of building block examples. And you'll see they're listed here for the board. So on the right side, you're going to see there's several examples here. For every single peripheral, for example, here this is ADC, you're going to find 5 to 10 different examples in different types of modes to show you all the functionality of those peripherals. For instance, there's a lot of communication ones. Again, for that RGB LED, it was an UART controlled one, so I'm just going to choose a UART based example here. So this one here is a UART Echo and 9600 baud. So when I click into this, basically it just shows you the code. So there's always going to be a description at the top explaining what's happening, and then the code itself down below. But the nice thing about this, since it's integrated with CCS, is if I import it over here in the top right, what's going to happen is when I come over here to CCS Cloud, it's actually going to bring the project in. And so again, this is our cloud-based code composer. This is a full IDE. So here I can actually open up the software, the projects here, open up the code. I can come in here. I can actually, start editing my code and doing all my development right here. This has full capabilities to actually build the project. So we click this little hammer. It's going to compile all the code, make sure that there's no errors. All right, looks like we're good. And then looks like we were already debugging, but if we come up here, we can actually click this little bug at the top and enter a debugging session. So this is actually going to flash this code down onto the Launchpad that I just have plugged into my PC with a USB cable. So this is going to flash in the example and give us basic live debugging control. So you have some step through commands over here on the right. You can actually step through and check, make sure your code is working correctly. Here you can set live breakpoints and run to those just to make sure that everything is working as expected. So with this, you can see I've imported a lot of different examples over here on the side. So some clocking ones, some timer ones. So it's very easy to take these examples, import them, test them or tune them themselves, and then put them together into something more cohesive like that RGB LED UART control that we've already provided in the 25 functions. All right, so that was a quick demonstration of what we have online for our cloud tools and our ecosystem. I have one more poll question we want to hit you guys with real quick, and then I think we're going to transition to live Q&A. So for our final poll question here, the question is, what type of functions that we mentioned in the webinar would you most likely integrate into your secondary MCU? Communications to other devices, mainly serial communications, PWM/timer functions, other system level functions. So this could be, again, reset manager or something else, or you don't use or don't think you're going to be using a secondary MCU in your design. Okay, looks like a lot of the majority of the people are saying other system level functions. This is kind of what we're seeing too. We want to make it very easy to use, so we have a lot of those kind of high level system overview or housekeeping functions in that 25 functions. But thanks for the feedback.
Great. Well, a few of you have already submitted questions, so we're going to jump right in. If you'd like to submit a question, type your question into the question window on the side of your screen and hit the submit button. While we're answering your questions, please complete the feedback form, which is located at the bottom of your screen. So for the first question, is there any particular reason you're targeting the FR/FRAM devices?
Yeah, I can take that one. So good question. When we're looking at system monitoring or housekeeping type of functions, we want to try to get you guys the lowest cost devices. And so today, the most cost competitive devices, we are across the board, I would say, pretty competitive, even with some of our flash devices, if you guys are aware of those. But today, especially for the really small memory densities, like 0.5K up to about 1632K, that's really where our FRAM devices are helping us really meet those price targets. And then for some of the examples that you saw, such as EEPROM emulation, you need FRAM to be able to do some of that stuff. So that's the reason why we have targeted these devices.
All right, looks like you convinced somebody. What's the best place to buy MSP430 parts, and how quickly can I get them?
Sure. Yeah, I'll take that one. So the best place to buy our parts today is going to be ti.com. And you can actually go on literally ti.com and go to any product page today and actually just hit order now. And you'll get the best price, the best web pricing pretty much on the entire web. So that's probably the best place to get started. And with ordering on our TI store, you actually also get a guarantee of really fast shipping. And so it ships out generally the day of the order. And so you can go ahead and put in an order for literally as many parts as you want, and it will ship out that day. And you'll get it probably within the next week or so, if not faster.
Excellent. Is it possible to replace multiple analog components on my board with a single MCU?
Sure. Yeah, I can take that one too. So the answer is yes. I think we gave some good examples in the design scenario, but also some of the examples that JD gave. But you can also use your MCU as for some of the standalone analog peripherals. For example, we have some devices that have op amps integrated on them. So if you want to get the benefit of using some of those op amps or even DACs, you can pretty much use the MCU purely for those. We also have devices with some precision ADCs, 16-bit, 24-bit ADCs on them. And so if you're really just looking for like an ADC or some specific analog part, you also could consider looking at just an MCU and having it and really just using the ADC on that device. So you can approach it that way, but you can also approach it from like what we've shown earlier today, which is taking in multiple discrete analog components.
All right. How can the main CPU communicate with the MSP430? How much code space is this going to take on both sides?
Hey, so I'll take this one. Usually the main MCU communicates with the MSP430 over serial communication. So this is going to be generally SPI, UART, or I2C. We support all three. In terms of the code size, it's going to be a couple hundred bytes. Again, we have in that other slide that Sheena shared, kind of spec'd some of these examples to give you a sense of what the actual code size is for each of those. And I'm pretty sure there's a code example for each one of those protocols.
Okay. This particular company is requiring field upgradable support. Is that possible using the MSP430?
Yes, I'll take this one as well. So field upgrades are possible. MSP430, I believe all the devices we sent promoted today have integrated ROM BSL. So this is a bootloader. These will either support, it'll be listed per device, but it'll support one of the protocols that we mentioned earlier, generally. So either SPI, I2C, and you'll be able to actually upload new firmware to the device over the BSL. So you can generally disable the JTAG and use the BSL to access the device and upload the firmware from your main MCU.
All right. Can you discuss a long-term support for these TI microcontrollers?
Yeah, I mean, sure, I can take that one. Yeah, we've been in the business of microcontrollers for over 15 years. I might even be shortchanging that. I think it's longer.
Over 20.
Yeah, so probably over 20. Okay. So we have devices today in production in our customers' systems that are 15 to 20 years old, and so we continue to support them. JD, our apps engineer, he's supporting customer. When customers are going and designing with older parts every day, and so the support model is going to be to continue to support every MSP device that we have out there. And yeah, that's pretty much all I would say about that. Is we are still shipping and helping customers with devices that are as new as that they came out last year and this year, as well as older devices that are over 15 years old.
Okay. Is it possible to have 2 or more I2C interfaces active at the same time?
Yes, I'll take that one. We do have devices that support 2 or more I2C interfaces, so it'll depend. We also have a software I2C library. That's pretty good. So we have had customers using some of the smaller devices that only have one I2C interface plus a software I2C. So we definitely have options for supporting more than one I2C bus.
All right. How would I identify the best MSP430 microcontroller for my application?
Sure. Yeah, great question. So I would say, we have a really great product selector guide or like a tool on our ti.com MSP page. And I think we should be linking that to you all, and it'll be included in the slides that get sent out after. But what I usually like to start out with is trying to understand what's the amount of memory that you need for your application, as well as what are some of the different peripherals that are needed. Like JD mentioned, right? Do you need multiple I2C lines? Do you need SPI, UART? How many of each? How many IOs do you need? So those are all good starting points. But once you kind of get those specs figured out, our product selector tool is actually it's excellent. I use it all the time. And so I would say that's a great starting point. But really helping, like narrowing down on the amount of memory that you need for your application, I would say that's probably top of the list for sure.
Okay. Do you support open source tools like GCC?
Yes, we do support open source tools, and we do have a GCC compiler for the MSP430.
Okay. Well, I'm afraid we've run out of time. We still have a lot of questions, and we'll be responding to you via email to answer all of your questions. This concludes today's presentation. On behalf of Electronic Design, I'd like to thank Texas Instruments for sponsoring today's event, and of course to all of you for joining us. Have a great rest of the day.
Thank you.